This is page 13 of the fault tolerance notes. It's going to be the final page, and we are going to look at an example where we have 7 generals and the number of disloyal generals M is 2. So we're going to start with General 1 being the commander, and it's going to broadcast a message to each of the 6 other generals. And the message that it's going to send is attack. And what happens, which I haven't described before, is that whenever a general sends a message, it prefaces that message with its ID number. So if General 1 is sending attack, the actual message it will send is 1:A, and instead of repeating the message 6 times here, I'll just use the ellipses. So it's going to send 1:A to the 6 lieutenant generals, and I'm going to label this as the broadcast stage. Now the 6 generals are going to implement the oral message algorithm to reach consensus about what they heard. And I'm going to keep a tally of the number of messages sent. So the message count, let's call that MC, for broadcast in this case is 6. Now I'm going to change color for the next, for the first, I guess, level of the OM algorithm. So General 2 is going to preface the message that it received with its ID number, and it's going to send it to the other generals, its other lieutenant generals, so 3, 4, 5, 6, and 7. So the message that it's going to send is 2:1:A. And it will send that to General 3, 4, 5, 6, and 7. So it's going to be sending 7 messages. I'll use the ellipses here again. And I won't show what 3, 4, 5, and 6 do, but let's just show what 7 does. So 7 is going to send the message that it received to Generals 2, 3, 4, 5, and 6. Now, before I do that, we need to know who are the disloyal generals. So let's just say that for this example, General 6 and General 7 are disloyal. And they can be inconsistent in what they send. They could send the correct value, the wrong value every time, something in between, or they could not send anything. Just to keep this simple, I guess, I'm going to have 7 send the opposite of what it heard, or it will always send retreat in all following steps of the algorithm. So that's one example. What will happen is L2, we can list what messages it has received. And so it's received, I'm going to leave a blank here. It doesn't send itself a message, but it will have received from Lieutenant 3 to attack, from Lieutenant 4 to attack, from 5 to attack, from 6, since it's disloyal, it will have received a retreat, and same from 7. So that's what Lieutenant 1 will have heard. Lieutenant 3 will have heard from Lieutenant 2 to attack. It won't send itself a message. It will have heard from 4 the same thing that 2 did, so we can copy the rest of this row. Okay, and so generals 2 to 6 will all have the set of messages that they've received. So you've got 6 generals all sending 5 messages and all receiving 5 messages. So the message count in this case is 6 times 5, or 30. So this was the OM algorithm with m equal to 2, and this is step 2 in the algorithm. Step 1 is just receiving the value from the commander, so in this case 2 received the 1a, and then it implements step 2, and it will receive back the 5 messages that I've shown here, and for each of those messages it's going to implement OM1. So let's use a different color for that. So 3 here will receive, or sorry, it will send to generals 4, 5, 6, and 7. And it's going to prepend its ID onto the message. So what it will send is 3, 2, 1A. And likewise, general 4 will prepend a 4 to the 2, 1A and send that out. 5 and 6 will all do the same. And then for the message that general 3 will have sent out, the receiving generals will send those out 4 times, and so on. So this is the OM algorithm with m minus 1, or 1, and this is still step 2, so we're still going down in the recursion. And what each general will receive, each of the lieutenant generals will receive here, is 20 messages. So let's, I need a bit more room here, so I'm going to start this. I'm going to create a table. So the first row will be for Lieutenant 2, and it won't receive anything from itself. We're going to have 6 spaces in the first row, and in the second row is what it receives from Lieutenant 3. And so again, it won't be telling itself what it heard from Lieutenant 3. Lieutenant 3 won't be telling itself what it heard, so there will be no message there. But Lieutenant 3 will report that it heard from Lieutenant 4, from Lieutenant 1 to attack. Lieutenant 3 will report that it heard from Lieutenant 5 from 1 to attack. 3 will report that it heard from 6 from 1 to retreat, and 3 will report that it heard from 7 that it heard from 1 to retreat. And then the next row is for Lieutenant 4. Again, we won't have a message from Lieutenant 4 saying what it heard from Lieutenant 2, but we will have a message from 4 saying what it heard from 3, which was to attack. It won't tell itself what it heard, so there will be a blank there. So the diagonal is empty here. So we skip that, and 4 will have heard from 5, from 1 to attack, 4, 6, 1, retreat, 4, 7, 1, retreat. And next row is for Lieutenant 5, so 5 will have heard from 3, from 1 to attack, 5 will have heard from 4, from 1 to attack. Won't report what it sent itself because it doesn't send itself anything. It will report that it heard from 6, from 1 to retreat, 5, 7, 1, retreat. And for the last row, Lieutenant 6 is disloyal, and for this scenario I'm going to say that it's always reporting to retreat, despite whatever it heard from the other lieutenant. So this will be 6 will say that it heard from 3, from 1 to retreat. 6, 4, 1, retreat. 6, 5, 1, retreat, nothing from itself, and 6, 7, 1, retreat. And for the last row, Lieutenant 7 will do the same thing. So it'll say it heard from 3, that heard from 1 to retreat. 7, 4, 1, retreat. 7, 5, 1, retreat. 7, 6, 1, retreat. And that's all the messages. So we've got 5 rows of messages there and 4 messages per row. So the communication cost, or the message count per general, is going to be 6 so each of the 6 generals, lieutenant generals, will receive 5 times 4 messages at this OM1 level of the recursive algorithm. Okay, and finally, for each of these messages that are received, these 20 messages, the lieutenant invokes OM0, and OM0, if you look at it, it just says use the value received that's been passed to it. So here, Lieutenant 4 received 321A, and that's in level 1. So it's going to evoke OM m-1, which is 0, with that message, and it will just return the value that it got in A. Now if no value is received, then it will use some kind of safe default like retreat. So each of these will just return. Now for Lieutenant 6 and 7, they'll have received an attack. If they're actually implementing the OM algorithm, will they record an R? Maybe. We don't really care what the disloyal generals do. And so now they're going to back out of the recursion. So with OM0, Lieutenant 2's table after that will look like this. 1, 2, 3, 4, 5, 6. It will have attack, attack, retreat, retreat, and then it will have attack, attack, retreat, retreat. For General 5, we'll have the values that General 5 reported will have attack, attack, nothing from itself, and then retreat, retreat. And from 6, we'll have retreat, 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 skipping 1 and then retreat, and then from General 7 it will be retreat, 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 retreat. These are the values that we'll have after returned by OM0. And as it backs out of the recursion, it does step 3. So now we're going to have OM1 step 3, which says to take the majority of the values received. So if I just back up here, Lieutenant 3 here sent out 321A, so it sent out the value that it received from 2, from 1, to the other 4 generals, and they all will have told it what they received. So it's going to take the majority of values that it heard from 4, 5, 6, 7, plus the one that it actually got from 2, and take the majority of those values. Okay, so this is for positions, or generals 2, 3, 4, 5, 6, and 7, and likewise 2, 3, 4, 5, 6, and 7. It's going to take the majority of those values plus the value that it received above. So if I just go back up here, the value from the commander, which is the value in green here, so we can see Lieutenant 2's vector values that it received, the 31A, 41A, 51A, 61R, 71R. So I'm just going to copy that down here again. So it received 31A, 41A, 51A, 61R, 71R. And I should have put a brace bracket at the end of L2's matrix there. So in step 3, we want to take the majority of values that we've been told that 3 communicated, that 1 communicated. So L2 is going to do this. It's going to have, it's going to replace, or it's going to take the majority of the values that it, the 3 1 values, and the majority of the 4 1 values, 5, 6, and 7. And so that's going to be attack. So we have in column 3 here 2 attacks, 2 retreats, plus the attack that it received in the OM2 stage. And likewise for column 4, we've got attack, attack, retreat, retreat, attack. So that's going to be attack. Same for column 5. Then for column 6, we are going to have all retreat, and for column 7, all retreat. So that is the values that Lieutenant 2 will have at the end of the level 1, or I guess it's the second level of recursion, when m is equal to 1. And then finally it will back out, and it will do the OM2 step 3. So L2 will calculate the majority of what it heard directly from the general, so I'll put that, the commander, so I'll put that in blue, and that was 1A. Plus these values above, which are attack, 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 retreat, retreat. And that is going to be 4 attacks, 2 retreats, and L2 will use as its value attack. So it has reached consensus with the other generals that it should attack. Likewise, generals 3, 4, and 5 will reach the same decision. We don't know what Lieutenants 6 and 7 will do. They are disloyal, which represents faulty components, and they may behave in some unreliable manner. But the loyal lieutenants will all arrive at the same decision about what value was communicated by the commander. So that is it for the Byzantine generals algorithm, and this is the end of the fault tolerance notes.